So this year, China is expected to produce over 100,000 humanoid robots. And, just let that sink in for a moment.
Yeah, it's an absolutely staggering number.
Right, because we aren't talking about, laboratory prototypes anymore, or those viral YouTube stunt machines that are meticulously programmed to do a backflip just for the camera.
Exactly. We are rapidly moving way past the R&D phase now.
We are. We're looking at 100,000 metal workers effectively clocking in for their shifts on the factory floor in 2026.
It completely shatters that old illusion of humanoid robotics as some, distant sci-fi concept. We're diving headfirst into real industrial mass production.
And that transition from the laboratory into the actual global economy is exactly what we are tracking for you today in this deep dive into the source material. We've pulled together a really fascinating stack of recent intelligence.
Right, some very heavy-hitting financial and industry data.
Yeah, we're synthesizing analyst reports from KB Securities and Serenity Analysis, plus integrating auto industry supply chain data from the Elec, Chosun, and MK. And we're cross-referencing all of that with highly specific reports on the global high-density battery market.
Because when a technology makes that shift from a science project to a multi-billion-dollar sector, you can't just look at the software anymore.
No, you really can't.
You have to analyze the physical constraints, the capital allocation, and honestly, the geopolitical maneuvering behind the supply chain.
And that is exactly our mission for you as you listen today. We want to look past those flashy artificial intelligence demos to uncover the hidden physical architecture. We're going to trace the gears, the specialized batteries, and the massive corporate bets that are quietly making this robotic worker a reality right now. So, okay, let's unpack this.
Well, the most logical place to begin is to ground this in physical reality, right? We need to look at what's actually happening in a manufacturing environment today.
Yeah.
And the contrast between the European approach and the Asian approach provides just a perfect lens for this.
Because to prove this isn't just theory, the intelligence points us straight to a French robotics company called Wandercraft. Now, they just secured a $75 million Series D funding round, which is
that is serious capital.
very serious.
Mm.
And they originally built their foundation on medical exoskeletons, those devices designed to help disabled patients walk again. But their latest move is a massive pivot. They've just deployed a humanoid robot named Calvin directly onto the floor of a Renault car factory in France.
And what's notable about Calvin's deployment is specifically how remarkably unglamorous it is.
Right, it's not doing anything flashy. Calvin is doing the most back-breaking, repetitive labor you can imagine. The field reports detail this robot leaning over a cart, lifting 25-kilogram tires, so about 55 pounds, and carrying them across a crowded factory floor to place them on a conveyor belt.
And it just keeps going.
Yeah, a sustained rate of 4 tires per minute.
See, the utility has entirely replaced the novelty there. Lifting heavy asymmetrical weight, balancing the shifting center of gravity while navigating around people, and doing it without ever getting fatigued, that is the definition of heavy industrial deployment.
It totally reminds me of the automotive industry's product cycle. Car manufacturers will spend millions building this hyper-futuristic concept car for an auto show, right?
Oh yeah, gull-wing doors, glowing tires.
Exactly, just to grab headlines.
Yeah.
But the vehicle that actually funds the company, the one that generates the billions in revenue, is the boring, ultra-reliable minivan.
That's a great point.
Calvin lifting tires is basically the robotic equivalent of the minivan. It lacks the viral aesthetic, but it proves the technology is finally street legal.
If we connect this to the bigger picture, that focus on heavy-duty, high-precision utility is really what separates the European and American targeted deployments from the sheer volume we're seeing out of Asia.
Right, because the data from CGTN reporting China's 100,000 units is, it's formidable.
It's massive. They are driving this with a 30% AI penetration rate in their industrial sector, heavily backed by their National AI Industry Investment Fund.
But wait, looking at that scale, I kind of have to push back on the global timeline here. If China has the centralized capital, the manufacturing base, and is already pumping out 100,000 units a year, aren't they poised to simply commoditize the entire robot market before the rest of the world even gets their premium models out the door?
Well, it's a valid concern, for sure, but you have to distinguish between dominating the low-cost general-purpose market and capturing that heavy-duty industrial niche.
Okay, how so?
China's volume will absolutely flood the market with lighter, less capable service robots. But manipulating a 55-pound tire on a crowded assembly line alongside human workers, that requires a completely different tier of physical durability.
Right. You can't just slap cheap parts together for that.
Exactly. You cannot brute force that kind of reliability. It requires a premium, heavily engineered supply chain, which means the true bottleneck isn't the software, and it isn't assembly speed.
It's the physical hardware inside the joints.
The physical hardware is everything. I mean, you can have the most sophisticated artificial intelligence model in the world running on the fastest silicon chips available.
Yeah.
But if that digital brain cannot translate its commands into physical torque, if it lacks the mechanical muscle to interact with the real world without snapping a joint, the AI is completely useless.
And the intelligence reports isolate this bottleneck down to a single critical component, which is the actuator.
Yeah, the actuator is where the digital actually meets the physical. It is basically the central nervous system and the muscular tissue of the machine all rolled into one.
Let's drill into the mechanics of that for a second, because the data from the ALEC and IBK research highlights a stunning financial reality here. Actuators make up an astonishing 60% of humanoid robots' total manufacturing cost.
60%.
Right. It's not the cameras, it's not the LiDAR, it's not the AI processors, it's the joints.
To understand why it commands that much of the cost, you have to understand the mechanism. An actuator is not just some simple electric motor.
Yeah.
It's a highly complex assembly. It comprises a high-speed electric motor, a really sophisticated gear reduction system, absolute encoders for positional awareness, and its own localized controller. It has to take high-speed, low-torque electrical energy and physically convert it into low-speed, high-torque mechanical force.
Right, because an electric motor naturally wants to spin at, what, thousands of revolutions per minute?
Yeah.
But a robot arm needs to move slowly and smoothly while lifting heavy steel.
Precisely. And to achieve that smooth reduction without any physical play or looseness in the joint, you have to use components like harmonic drives. These are gears machined to microscopic tolerances.
Wow.
If there is even a single millimeter of slack in the shoulder actuator, by the time that error travels down the arm to the hand, the robot drops the tire.
Right, it amplifies down the line.
Exactly. Manufacturing those flawless high-torque joints at scale is incredibly difficult and notoriously expensive.
Well, the Boston Dynamics Atlas robot, which is widely considered the gold standard for a dynamic bipedal movement, that one requires exactly 31 of these highly engineered actuators per unit. And the reports show a massive supply chain shift happening right here. Hyundai Mobis, which is a massive automotive parts supplier, has essentially locked in the contract as the exclusive actuator supplier for Boston Dynamics.
Yeah, they are.
They're actually building a dedicated facility in the United States designed to manufacture over 350,000 actuators annually.
What's fascinating here is how Hyundai Mobis is engineering not just the physical hardware, but the corporate finance required to make mass adoption viable in the first place.
I really want to dig into that financial engineering because the math just doesn't seem to add up at first glance. If a single harmonic drive actuator is a masterpiece of micromachining, scaling up to 350,000 units doesn't magically make them cheap.
No, it doesn't.
So if the joints remain 60% of the cost, how does a manufacturer ever bridge that massive capital gap? How do they bring the final robot down to a price point where a normal logistics company can actually afford to buy a whole fleet of them?
So you're identifying the classic valley of death in hardware manufacturing. That's where the upfront capital expenditure just destroys the company before the product ever becomes profitable.
Right.
Hyundai Mobis is bridging that gap by weaponizing its legacy business. They operate a massive after-sales, or AS, division. This is the unglamorous business of selling replacement brake pads, oil filters, and alternators for the millions of internal combustion Hyundai and Kia vehicles already on the road globally.
Ah, so they have an incredibly predictable, high-margin cash cow.
Exactly. They are taking the stable, massive profits from a dying internal combustion engine era and aggressively funneling that capital into the robotic workforce of the next century.
That's brilliant.
The internal reports indicate they are even considering divesting or selling off their traditional bumper and lamp manufacturing divisions entirely. They are actively shedding their legacy automotive identity just to focus their engineering talent and capital entirely on core robotic components.
That is a staggering capital bridge. They are essentially internally absorbing the brutal upfront costs of perfecting that actuator supply chain so that the final price tag of the robot doesn't just bankrupt the end buyer.
By shielding the robotics division from those immediate market pressures using their automotive profits, they can afford to play the long game. They can wait until the manufacturing costs naturally decrease through economies of scale.
which perfectly transitions us into the adoption projections. Because getting from localized factory tests to millions of untethered robots requires predicting human behavioral economics, really. And the financial institutions in our source stack are sharply divided on how this is actually going to play out.
Yeah, it's a classic debate over technology adoption curves.
On one side, you have IBK Research modeling a very linear, steady growth path. They are projecting roughly 11,290 Atlas units manufactured by 2028. But then Serenity Analysis looks at the exact same data and models a violent S-curve adoption. They're projecting up to 140,000 units by 2030.
See, an S-curve is terrifying for incumbent businesses because it implies a major tipping point. The adoption rate stays relatively flat for years while the tech is expensive and kind of buggy.
Yeah.
But the moment the utility crosses a specific cost threshold, adoption doesn't just climb steadily, it explodes vertically. Suddenly, every major logistics and manufacturing player realizes that if they do not automate immediately, they will be totally outpriced by competitors who did.
And looking at Hyundai Motor Group's master plan, they are clearly betting billions on that vertical S-curve explosion. I mean, their internal roadmap targets the production of 30,000 Atlas robots annually by 2028. But instead of flooding the open market to recoup their R&D costs, they plan to initially deploy over 25,000 of those units directly into their own Hyundai and Kia automotive assembly plants.
That internal deployment is easily the most strategic maneuver in their entire playbook. It's the ultimate example of vertical integration.
Really. Because I kind of had to challenge the economics of that move. Deploying 25,000 multi-million-dollar robots into your own factories feels like an incredibly expensive vanity project. Are they essentially just paying themselves to artificially inflate the production numbers? To make the Atlas platform look like a commercial success before any third party is actually willing to take the risk?
I get why it might look like artificial inflation from the outside, but in complex hardware development, this is a vital strategy known as dog fooding, consuming your own product.
Right, eating your own dog food.
Exactly. Because if Hyundai sells an unproven, newly minted robotic fleet to a third-party logistics firm, and the harmonic drives seize up under a continuous load, or the software hallucinates and drops a car chassis.
Oh man, that's a nightmare.
Hyundai faces catastrophic brand damage and massive liability. The stakes are just way too high on a live third-party factory floor.
But if a robot fails inside a Hyundai factory?
It is not a public relations disaster. It's a proprietary engineering lesson. Deploying 25,000 units internally creates this massive enclosed sandbox. It allows them to stress test those new Mobis actuators under brutal, continuous, real-world conditions. And more importantly, it creates a closed data loop.
Because hardware is only half the equation.
Yeah.
The AI actually needs training data.
Precisely. Their software division, Hyundai Autoever, requires millions of hours of operational data to perfect the AI control systems. By running 25,000 robots internally, they generate a proprietary industrial data set that their competitors simply cannot buy.
That's a huge advantage.
They refine the physical joints, they perfect the digital brain, and only when the system is virtually flawless do they finally release it to the open market.
So it's basically a 25,000 unit incubator. That causal loop where flawless hardware drives massive data collection, which in turn perfects the software, is exactly why KB Securities Project's Hyundai will eventually capture 60% of the high-priced industrial humanoid market.
And that dominance leads directly to the cost threshold that triggers the S-curve we discussed earlier.
Right, because KB Securities projects that by 2035, the unit cost of an Atlas robot will plummet to roughly $190,000. Now, upfront, obviously, that is a massive capital expenditure, but corporate finance doesn't really look at upfront costs, do they? They look at amortized lifespan value.
Oh, yeah.
So KB calculates that over its operational life, that robot equates to an annual cost of roughly 48 million won, which is about $35,000 a year.
Think about that. $35,000 annually for a heavy industrial worker that does not require sleep, is completely immune to physical injury, does not require healthcare benefits, and can operate continuously in totally hazardous environments.
It's wild.
That is the exact mathematical tipping point where human labor just becomes economically unviable for rote industrial tasks.
Okay, so we've established the mechanical muscles through Mobis, and we have decoded the internal deployment strategy to perfect the AI. But there is a glaring physical constraint that makes all of this completely irrelevant if it isn't solved. I mean, Hyundai can build 350,000 flawless actuators, but if the robot is tethered to a power outlet on the wall, it's useless on a dynamic factory floor. Energy density is the ultimate make-or-break metric here.
It really is. Storing and discharging massive amounts of energy within a mobile bipedal frame is the single greatest physics challenge in humanoid robotics right now.
And the intelligence from the Battery Tech Network reports indicates that LG Energy Solution is stepping into this void. They're actively supplying highly specialized 46 series ternary cylindrical battery cells for the Boston Dynamics Atlas, and reportedly for Tesla's Optimus program as well, because the architecture of a robot is completely hostile to traditional battery replacement.
Right, it's very different from a car.
In an electric vehicle, engineers have this massive, flat skateboard chassis stretching between the axles where they can just layer thousands of heavy battery cells. But a humanoid robot has a strict volumetric limit. It has to fit in the human torso.
Right, because the square cube law and basic bipedal physics dictate that a robot cannot simply carry more weight to get more power. If you add heavy, low-density batteries, the robot expends the majority of its energy simply supporting and moving its own mass,
leaving no torque available to actually lift the 55-pound tire. Okay, here's where it gets really interesting. Because energy density isn't just a physics problem anymore. It has become a massive geopolitical flashpoint. Our intelligence stack shows a distinct macroeconomic shift going on. Now, as impartial observers analyzing the data clearly indicates that the United States is actively maneuvering to construct a high-tech robotic supply chain that is decoupled from Chinese battery manufacturers.
And that geopolitical friction creates an unprecedented vacuum in the market right now.
It does. And that vacuum is providing a massive opening for South Korean firms, specifically LG Energy Solution, to establish absolute dominance in this hyper-specialized battery space. SNE Research is forecasting a global fleet of 53.3 million humanoid robots by 2040.
That's a huge fleet.
Yeah. That translates to a $10.5 billion specialized battery market effectively up for grabs. But I am still really hung up on the raw chemistry of this. The physics just seem impossible. We all struggle to keep a basic smartphone, which is just powering a tiny glass screen right alive for 12 hours.
Oh, for sure.
You are talking about powering 31 high-torque harmonic drives, deadlifting steel and rubber all day long. How do you pack that much kinetic potential into a torso without the thermal runaway just melting the entire robot down to slag on the factory floor?
This raises an important question about the specific chemical architecture LG is actually utilizing. The 46 series designation simply refers to the physical dimensions of the cylinder, so 46 millimeters in diameter. The real technological breakthrough is the ternary chemistry.
So break that down for us. What makes ternary chemistry the only viable option here?
Well, a ternary cell utilizes a highly controlled combination of 3 specific metals for its cathode, typically nickel, cobalt, and either manganese or aluminum. It is a very delicate chemical balancing act. The nickel is responsible for the extreme energy density. It allows the cell to pack a massive amount of electrons into a tiny physical volume.
Okay.
And the cobalt provides the structural stability, ensuring the cell doesn't rapidly degrade under heavy loads.
So it's vastly different from the batteries used in, say, lower-cost electric vehicles or grid storage.
Entirely different. A lot of EVs use lithium iron phosphate or LFP batteries. Now, LFP is significantly cheaper and highly stable, but it is physically bulky and heavy. If you put LFP cells in a humanoid robot, it just becomes too heavy to lift anything of value. Ternary chemistry maximizes the power-to-weight ratio, which is literally the only metric that matters for a bipedal machine.
But what about the heat? I mean, discharging enough voltage to lift a tire over and over must generate massive thermal friction.
And that is the secondary challenge of ternary cells. They are highly volatile. So to prevent thermal runaway, or as you put it, melting into slag, the 46 series cells are engineered with internal cooling channels and structural thermal management. That allows the battery to safely dump massive amounts of power instantaneously without overheating.
Wow.
But manufacturing these volatile chemical cocktails with 0 defects at a scale of millions of cells requires a level of precision that currently only a handful of companies globally, like LG, Samsung, and Panasonic, can execute reliably.
The picture that emerges from all these sources is honestly a perfect storm of convergence. The artificial intelligence models have finally matured enough to actually understand physical environments. The legacy automotive giants are bankrolling the mass production of the physical actuators. And the chemical engineers have finally compacted enough energy density into a steel cylinder to cut the power cord.
Yeah, the primary barriers to entry are no longer scientific discovery or theoretical physics. The barriers are now strictly rooted in supply chain execution and capital allocation.
And that is the ultimate takeaway we want you to absorb from this deep dive into the intelligence. When we talk about the next decade of technological revolution, it isn't just going to be defined by generative AI chatbots drafting emails or large language models generating images on a screen for you.
No, not at all.
The defining shift of the next 10 years is the physical supply chain. It's the harmonic gears, the 46 series ternary batteries, and the massive internal logistics networks that are finally pulling artificial intelligence out of the cloud and giving it a physical, moving body in our physical world.
We are essentially witnessing the Industrial Revolution compressed into a single, highly accelerated decade. And, if we follow these supply chain projections out to their logical conclusion in 2035, it really forces a profound economic and societal
I
reckoning.
definitely want to hear your read on that. Where does this leave the human element in all of this?
Well, consider the convergence of these two timelines. By 2035, the amortized capital cost of a heavy-duty, tireless humanoid worker drops to roughly $35,000 a year. At the exact same moment, generative AI software is rapidly absorbing and automating entry-level digital and cognitive desk work.
Right.
If the rote physical labor in our warehouses is performed economically by machines, and the rote digital labor in our offices is performed instantly by software, what exactly constitutes an entry-level job for a human being entering the workforce? In a few decades, will human physical labor transition from a basic commodity into a premium artisanal luxury?
Will we eventually pay a premium surcharge just to have the guarantee that a human hand assembled our vehicle or, carried our goods? It completely inverts how we value human effort. The robots are no longer just doing backflips in a laboratory. They're clocking in, and they're about to rewrite the global economy.